Now we move to derivatives of inverse trigonometric functions. Firstly, if y is equal to arcsine of u, that's what I call sine inverse. I call it arcsine u. Then it means u is equal to sine y. Then we differentiate u equal to sine y with respect to x. And that gives us left-hand side, it will be du over dx. But then u is a function of y, and y is a function of x. So that means we'll have the derivative of sine, which will be cos. And therefore, because the argument is y, we'll have cos y here, multiplied by the derivative of y, which is dy over dx. And then, because we're trying to find the derivative of y equal to arcsine u, we need to make dy over dx the subject. Therefore, we'll take cos y to the left-hand side. So that gives us 1 over cos y multiplied by du over dx. That's what we have here. Dy over dx is equal to 1 over cos y over d over dx. And then we know that sine squared y plus cos squared y is equal to 1. Therefore, we can make cos y the subject. It will just be the square root of 1 minus sine squared y. Then in place of cos y in that formula, we substitute. Therefore, dy over dx will be equal to 1 over the square root of 1 minus sine squared y multiplied by du over dx. We have not lost that du over dx. I hope you're noticing. And then because we had said u is equal to sine y, therefore sine squared y will be equal to u squared. Therefore, we have dy over dx equal to 1 over the square root of 1 minus u squared multiplied by du over dx. Therefore, when we want to find the derivative of arcsine u, its formula is 1 over the square root of 1 minus u squared multiplied by the derivative of u with respect to x. Now, as an exercise, we need to prove that the derivative of arc cos is the negative of 1 over the square root of 1 minus u squared times du over dx. Secondly, prove that the derivative of arctan u is equal to 1 over 1 plus u squared times du over dx. Please do these exercises. Follow the same route. Remember, you just simply say y is equal to arc cos u, and then it means that u will be equal to cos y, and then you do the differentiation. Same here, you say y is equal to arctan u, and therefore that means you can make u the subject. It becomes u equal to arctan y. And then you continue the differentiation. Follow the same steps that we've used in the previous slide. Here are some examples that we're going to use based on the derivative of arcsine u, arc cos u, and arctan u. Number 1, find the derivative of y equal to arcsine of 4x. Please remember that now we have f of x here. That is our u. And therefore, we need to multiply by the derivative of our argument, which is 4x. So therefore, because we know that the derivative of arcsine of any function, would say u, would be equal to 1 over the square root of 1 minus u squared, and our u in this case is 4x. And then we multiply that by du over dx. That means the derivative of the argument of arcsine. So all in all, you can simplify this. It becomes 4 divided by the square root of 1 minus 16x squared. Let's go to the second example. Given that y is equal to 2 times arc cos of the square root of 2 minus x. Now note that u is the square root of 2 minus x. Trying to find this derivative, note that we take 2 out because it's not going to affect us, and remember that the derivative of arc cos is negative of 1 over the square root of 1 minus u squared multiplied by du over dx. Hence we have negative 2 there, multiplied by 1 over the square root of 1 minus the argument of arc cos, which is the square root of 2 minus x all squared, multiplied by the derivative of the square root of 2 minus x. And we know the derivative of the square root always gives us 1 over 2 square root. Okay? And then the argument of the square root is 2 minus x. We place it as it is, and we multiply that by the derivative of the argument of the square root. Don't forget that. Hence, we have a negative 1. And then we can simplify all these expressions. And please make sure when you are answering these questions on differentiation, read the instructions. If the instructions say simplify fully, then it means you don't stop here. You continue simplifying, making sure, because you know the square root of 2 minus x all squared gives you what? 2 minus x. You simplify, you'll have 1 minus 2 plus x. You can be able to simplify that. That is x minus 1 under that square root sign. 2 and 2 will cancel. The negative and the negative will cancel. So you can be able to simplify this into a very, very simple expression. Please try it and make sure that you. Number 3, we've been given that we have x squared plus 1 multiplying arctan of x, and that whole expression is subtracted. X is subtracted from it. Now let's go to the first term. The derivative of the first term. What do we do there? It's the product rule. It's the product of two functions, x squared plus 1 and arctan of x. So what do we do? Product rule. I took down x squared plus 1 and differentiated arctan. And arctan gives me 1 over 1 plus x squared. Note that this 1 is just the derivative of x plus, take down arctan and multiply that by the derivative of x squared plus 1, which is 2x. And then we have the derivative of minus x, which is just negative 1. You can simplify this whole expression, and you can see that the first term will be 1, and the next expression will be 2x arctan of x, and this next expression is minus 1. So that means your answer will just be 2x arctan of x after you've done your simplification. Try it and let's see. Number 4, we have again, the first term is a product of two functions, x arcsine 2x, and the next one is half times the square root of 1 minus 4x squared. Now let's do this and let's see. The first one, because the product of two functions, we do the product rule again. Note that I differentiated x first, so that gives me arcsine of 2x. Then, as the first term answer, plus, we take down x and find the derivative of arcsine of 2x. Remember that you have to have the derivative of 2x in your numerator, which is 2. So it's 2 divided by the square root of 1 minus 4x squared. Note 1 over the square root of 1 minus 2x all squared is the derivative of arcsine 2x, and that would be multiplied by 2. And then plus. Now you've got the product of those, you've got the terms, two terms that are a result of the product rule of the first term. Now we go to the second term. Half multiplied by the square root of 1 minus 4x squared. Note that half is just a constant, you take it out. Then you come to the square root. The square root always gives you 1 over 2 square root. And then the argument of that square root sign does not change. But then in the numerator, you must have the derivative of that argument. So the derivative of 1 minus 4x squared is minus 8x. You can simplify this expression and you give us the correct answer. And note that the last two terms, you can add them up because they're exactly the same. Number 5, we have the square root of 2 pi minus arcsine 4x. As we know, the derivative of a square root is 1 over the 2 times the square root. Note the argument of the square root sign does not change. Instead, you will multiply that term by the derivative of the argument. Note 2 pi is just a number. So the derivative of 2 pi is what? It's 0. We have that negative there. And we know arcsine gives us 1, the square root of 1 over the argument of arcsine squared in the denominator, and it has 1 in the numerator. But now, because the argument of arcsine is not x, it's 4x, then we have to have the derivative of 4x in that numerator, which is 4. Still, you can simplify this because 4 and 2 will find a way to cancel each other. And here in your denominator, we have the square root of 1 minus 16x squared. Let's go to the next slide. In this slide, now we move from inverse trig functions to hyperbolic functions and their inverses. Please go through your notes that are available on the Blackboard, that is my tutor, and more exercises that are available there, and make sure that you are able to do as many exercises as possible. Here we'll be dealing with rules 22 to 33 in the table that I had inserted in the first differentiation slides. Now let's do some examples based on rules 22 to 33 of that table. We have here t squared cot h t, the derivative of which is, using the product rule again, the derivative of t squared is 2t, and I take down cot h t as it is, plus take down t squared, and the derivative from the tables of cot h t is negative cosec h squared t. And you may be able to simplify that. When you simplify, we will just take out the negative sign. We go to B. y is equal to the square root of pi minus t squared multiplied by tan h to the power 4, and the argument of tan h to the power 4 is pi t. As we can see, it's the product rule once again. Two functions. First function is the square root. So that means you'll have 1 over 2 square root of pi minus t squared multiplied by the derivative of the argument of the square root, which will be negative 2t, because you know the derivative of pi is 0. Hence, we have negative 2t divided by 2 square root of pi minus t squared multiplied by the second function as it is, plus the first function as it is multiplied by the derivative of the second function. I hope you still remember, because this is tan h to the power 4. The first thing you differentiate is the power 4. So that means you'll have 4 tan h to the power 3 pi h. That's where you start. Multiplied by then the function itself, tan h of pi t. Pi t has the derivative pi, okay? And tan h, according to the tables, has got the derivative sec h squared. Hoping you notice the first thing, again, we differentiated the power, which is the outer function, so it becomes 4 tan h to the power 3 pi t. And then thereafter you come to the function itself, the trig function, tan h, and you differentiate that, which gives you sec h squared pi t. And then you differentiate the argument, which is pi t, and pi is just the coefficient, so that means your answer is pi. I'm hoping that we are together. Slide. We go to C. The function given to us is sec, and the argument of sec is arctan of negative x. Here, we need to make sure that we differentiate sec first and then tan arctan and then negative x. I'm hoping that we're together. Okay, let's go. Note the argument of sec is arctan of negative x, and the derivative of sec is sec 10. So that means it will be sec of arctan minus x times 10 of arctan minus x. Thereafter, you go back. What is the derivative of arctan? Derivative of arctan is 1 over 1 plus x squared multiplied by the derivative of negative x, which is negative 1. I'm hoping we understand each other. We started by differentiating the outer function, which is sec, and it gives us sec 10. Please don't leave behind the argument of sec. That is why you take it down as it is, multiplied by the derivative of arctan, and then multiplied by the derivative of negative x. We go to D. We are given arcsec of x ln x. According to our tables, we have to have the derivative of the argument of arcsec in the numerator divided by the derivative of arcsec. Now, okay, the derivative of arcsec is the argument x ln x multiplied by the square root of the argument squared minus 1. I hope you remember that it's going to be f prime of x in the numerator divided by f of x square root of f of x squared minus 1. Or should I say u? If it's u here, it will be the derivative of u with respect to x divided by u square root of u squared minus 1. And then we come to the derivative of x ln x, product of two functions. So I started by differentiating x, which gives me ln x, plus x times the derivative of ln x is 1 over x. So x times 1 over x gives me 1. Please check and make sure that everything is correct. We have used the chain rule in our second last problem in the previous slide. What does it mean? It means with just differentiation of composite functions. Remember, composite functions are functions like f of g of x or g of f of x. So it means it's a function inside another function. And we had used an example like, for instance, the square root of x squared plus 1, where x squared plus 1 is another function and the square root of x is another function. So you combined two functions to make one function. So now let's quickly get into it. We have y is equal to u of x. We want the derivative of y with respect to x. It means y is a function of u, but u is a function of x. So you can only differentiate y with respect to u. That's why it's going to be dy over du. But u now is also a function of x, therefore you have to multiply by the derivative of u with respect to x, because now you've got a function inside another function. So that's exactly what we're going to be doing here. Make sure that you realize when you do differentiation, you differentiate the outer function first, multiplied by the derivative of the inner function. That's exactly what we've done. You differentiate with respect to u, which is the outer function, and then you differentiate with respect to the inner function, which is x. Let's do this. Example 1. You've got 1 minus 3x squared all to the power 4. As you notice, the outer function is the power 4. The inner function is 1 minus 3x squared. So we are going to differentiate the power 4 first. So we know if it was just x to the power 4, it will be 4x cubed. That's exactly what we're going to do here. So we have 4 into 1 minus 3x squared all to the power 3. And then, because of this rule, we have to multiply by the derivative of the inner function. So the derivative of 1 minus 3x squared is negative 6x. Please note, differentiate the power first. It's 4 into 1 minus 3x squared all to the power 3. And then multiplied by the derivative of the inner function, which is negative 6x. Let's go to the next example. Now we're in example 2. We're given 8 multiplied by the square root of 1 plus square root of x. As you can see, this is a composite function of 3 functions. But let's not go deeper than that. Let's find this derivative and let's see. 8 will remain, and then we go straight to the square root. The derivative of the square root is 1 over 2 square root. The argument of the square root does not change. All right. Then we multiply that by the derivative of what's under the square root sign. That means the argument of the square root. The derivative of 1 is 0, but the derivative of the square root of x is 1 over 2 square root of x. I hope you notice we took 8 out, we multiplied that by the derivative of the square root of 1 plus square root of x, which is 1 over 2 square root of 1 plus square root of x, multiplied that by the derivative of what's under the bigger square root sign, which gave us just 1 over 2 square root of x. Now let's go to a more complex one. Let's see how we're going to do. We have been given sine squared, and the argument of sine squared is e to the power 2 sine t, 2 sine squared t. Let's go. Remember, we're moving from left to right. So the first thing, we start by that power, which is 2. So, which is 2, we'll just get 2 sine of that argument. Note the argument does not change. Multiplied by, now we come back to cos, to sine. The derivative of sine is cos. The argument does not change. Multiplied by, now we come to the angle. The derivative of e to the power sine squared t, the exponent remains the same, no change. Multiplied by the derivative of that power. Note in that power we've got squared, so we have to start by finding the derivative of that power, which is 2 sine t, and then thereafter the derivative of sine t, which is cos t. Again, we started with the power, so it became 2 sine of that exponential function multiplied by the derivative of sine, which is cos of the exponential function, multiplied by the exponential function, the derivative. It gives us always, once you differentiate the exponential function, you always get the exponential function multiplied by the derivative of its power. And then the derivative of that power is 2 sine t first, multiplied by the derivative of sine, which is cos t. I'm hoping we're together. Let's go to number 4. We've got 10, and the argument of 10 is sine, and the argument of sine is the square root of 1 plus t cubed. Let's do this. Start from left to right. The power is just 1, so no problem here. We start with 10. The derivative of 10 is what? Sec squared. And note, we take the whole argument of 10 down with us. So we've got sec squared of sine of square root of 1 plus t cubed. Multiplied by, now we are here. Inside the argument of 10, we have the derivative of sine, which gives us cos. And note, now the argument of sine is the square root. So our answer will be cos of the argument of sine, multiplied by the derivative of the square root, which is 1 over 2 square root of the argument itself, multiplied by the derivative of 1 plus t cubed, which gives us 3t squared. I'm hoping we're together, guys. Number 5. Ln of ln of ln x. Let's do this. We start from the outer function. From our rules, the derivative of ln x is always 1 over x. So that means if the argument of this ln, the outer ln, is ln of ln x. So that means we'll have 1 over ln of ln x multiplied by the derivative of ln over ln x. Now we differentiate ln. Again, we have 1 over ln x multiplied by the derivative of the last ln x, which is 1 over x. I'm hoping you are with me. And if you are getting number 5, then that means you can do number 6. All right, you can do number 6 on your own. But what I would advise you to do, because now we have a cube root here, so change y to be to the power 1 over 3. So we have x square root of x to the power 4 plus 2x into the 4th root of 8 over x plus 2, all to the power 1 over 3. So try to do this. Remember, you have to start with the outer power, then this is a product rule because of what x times the square root, and then multiplied by the derivative of the argument of the second square root sign, which is 3x to the power 4x to the power 3, plus you've got a product rule again. So just try and do this and see how far you go. All right, and then consult me if you experience any problems. Then we go to number 7. We've got, now we go into hyperbolic functions. Number 7, cos of the square root of sine of tan of ln t. Okay, left to right once again. So we have the derivative to be sine h, which is shine. And then we take down the argument of cosh as it is, multiplied by the derivative of the square root, which we know is 1 over 2 square root of that argument as it is, multiplied by the derivative of this argument. We start with sine, which gives us cos, and the argument of sine was tan of ln t, multiplied by what's the derivative of tan is sec h squared, and the argument was ln t, and then at the end you have 1 over t. You're multiplying from left, the derivatives from left to right. Some exercises for us to do. Okay, number 1, what is the derivative of cos of x to the power negative 1 plus cos x all to the power negative 1 plus arc cos of x. Note all these three are different functions. They are not the same at all. And then you do number 2, which is arctan of arctan t. And then number 3, arctan of e to the power negative t square root of t. And then the last one, arctan of tan of arctan t. Let's do this and let's see how far we